A quick overview. Each line is a compilation unit. There are two separate reactive systems, one for the code and one for the application. Bidirectional features arise from data flow between components. It's a push-based reactive system, so if there's no data change, nothing happens. My perspective on programming systems is limited, but it looks something like this. I'm exploring the space up here. It's built on top of JavaScript and the web. It uses JavaScript numbers and strings, but wrapped in reactive containers. So we have two coupled reactive systems, one for the code here and one for the live program. Here's a bit more details, and let's go through it using this example here. The editor is just the HTML text area. Yeah, the end goal is a very different kind of editor, but now it's a text area and it's two-way synchronized to the database. So instead of indented text, we get individual lines with order and parents. The intention was to use the same database also for other resources like WebGL shaders and JavaScript code, which should also be hot reloadable. This is why it says run here. It's the entry point for the spine code. A block is what I call a line that has been instantiated, and the blocks exist in a tree structure as well. But to get to live blocks, we first need to parse the text. The parser is inspired by JSON and designed to have a generic and loose syntax. It leaves most of the validation up to the next abstraction. Inspired by CoffeeScript, argument parentheses can be omitted. Inspired by Lua, there is only one container type, items. The output of parsing is based on a single structure and is mostly strings. Reverse parsing is basically just appending the strings recursively. Here's the callback where the live values are serialized. And it's a bit simplified because there's also a callback here in the real code. I don't have much experience with language parsers, so I probably don't know what I'm doing, but post a video here for implementation details. That was the parsing part. That's how we get from the text here to the AST here. Now inside the block, that's where we recursively iterate the AST, and the result is a connected graph of live components. Here's an example of 3 blocks and their connected graphs. The plus here is a reactive operator. It will sum 1 and 2, which is 3, and it will output the result here to C. However, if some other part of the system changes this to, say, 10, the operator will run in reverse, and it will do 10 minus 2, and it will output 8 here to A. And this will cause this line to be reverse parsed and its source code updated. Let's try this out. To keep things simpler, change always flows to the left, but it would be nice with an operator to make terms read-only, like the exclamation mark in Sketch and Sketch. If we multiply by 0, the points get stuck. It's because the multiply operator cannot reverse this operation. A similar thing happens with clamp when we move outside the interval. The line is a kind of debug output, showing that some change that we wanted to make could not be absorbed by the expression. Round is a similar example. It creates a snapping behavior. For round, only integers can be absorbed, and it's the absorbed value that should pass through to the input. When implementing components, I think of this as conserving information. It seems to be a useful guide as long as the reverse flows to a single input. In this example, we have values A and B represented by the gray squares here, and we have a blue one which jumps when I press Control. So when Control key is down, this code here is instantiated. But this does not actually change the C here. Instead, a new reactive value is created, which exists in all the lines that comes after. So the namespace is distributed in the block tree, and it uses backward deep traversal to look up symbols. This enables a way to rewire the program that aligns with our intuition about imperative programming, and at the same time increase the expressive power of the language. For a simple case like this, we could use array indexing instead. And it would would have the same effect. Or we could use the mix function, which is non-binary. And then we could smooth it. But what happens if we put it right in the middle? Yeah, then we move both of them. Let's draw a line to explore the behavior further. This shows how reverse changes are distributed to the inputs of the mix function. When the mix is 0.5, 100% of the change goes to both, and over 1 it decreases inversely. Here we have a typical rectangle gizmo. You can move it or its sides or its corners. But I want you to notice something here. Mathematically, center minus half the size is just the same as the minimum point. So let's simplify the code here. It looks the same. But when we move the rect, it just moves the corner now. So while bidirectionality enables a way to express behavior, we have to slightly revise our expectations about expressions. In this example, I can move this point using the arrow keys. I can also smooth it. Now this is not very far from a minimal game. So now I can hunt the green apple here. And cheating is also possible. So there's actually a write operator here for this to work. And I'm not sure if this is a good idea. Anything that feels like an event maybe should rather run imperative code. Here we have a slider abstraction. Def is like class, and it uses bidirectionality to define behavior, but the data is kept externally. For most user interaction, we don't want the change to flow all the way to the source code. By using state, we indicate that the variables should be part of the app state instead. The bad news. This was an attempt to build a different kind of language, but I couldn't get it stable enough to be useful. So about 10 years ago, I gave it up. But eventually I felt itch to get back into these ideas for some demo scene projects. So in C#, I made a quick port of the parser and I started to re-implement the reactive components. Coming back to Spine for this presentation, I was able to fix some of the old issues, but it's still a mess. When bugs emerge from the interaction of multiple components, it takes a lot of effort to understand what's happening. And even when you do, it's often not clear what to do about it. Issues often relate to execution order and stuff like async recursive removal and incremental updates. You know, the stuff you usually avoid in any software project. Of course, if you have your source code reactively coupled with your program, you might get a fun feedback loop like this. Yeah, the source is changing here by itself, or by, yeah, it's a loop. What can we learn? Add more metadata to reactive values. Yeah, do this early, because it also helps when debugging. Unify your APIs. Having the same kind of disposable simplifies code a lot. Reduce the number of subsystems that are work in progress. It sounds so sensible, but how fun is it? You might as well just say, don't implement your new language in another experimental language. Would you like to read a long list? Pause now. Big thanks fly out to organizers and reviewers of Live 2025. Magnus Lidström for his early feedback and inspirational software practices. Brett Victor and the demo scene. And to you for watching.